Welcome back to your Algebra 1 Semester 1 review in December. Just as a reminder, the problem number over here might not match up to the problem on your review sheet, but just roll with it. If your problem matches the one here, you're in the right spot. So, this is asking about compound inequalities, and compound inequalities come in two forms. Either they're connected by OR, which means we need to look at both equations. Either one could be true, or the other one could be true. Or we need to, if these aren't connected by OR, we might have an equation like and I'll give you an example of an and equation really quickly. You might have something like -2 is less than x plus 3, which is less than 5. Right? This is technically connected by and. X plus 3 is both greater than -2 and smaller than 5. The way you'd solve this is you would maybe just subtract 3 from all sides. There's 3 sides here, and we'd get that -5 is less than x, which is less than 2. Right, so there's our and situation. However, this is not an and situation, this is an or. So we'll just keep that over to the side, and we'll work with this or. We have 2x plus 5 less than 1, or 4x minus 7 is greater than or equal to 9. We're going to go ahead and solve each one just using SADMAP. We do our addition and subtraction first, and we end up with 2x is less than -4, and of course we need to divide by 2. And when we do that, we end up with x is less than -2. Notice I did not flip this inequality sign. We only flip the inequality sign if we multiply or divide by a negative number, and this is a positive. So it keeps everything the same, and we get one piece of the puzzle done. The other piece comes from the other part. We need to add 7 to both sides. When we do that, we end up with 4x is greater than or equal to 16. Of course, we still need to isolate x by dividing by 4. And we end up, again, not flipping the inequality sign, no negatives being divided by here, with this. So this tells us x has to be less than -2, or x has to be greater than or equal to 4. Now, a is out. A tells us that x has to be a number that's both greater than -2 and less than +4. So a number greater than -2, less than +4 would be like 1, or 2, or 3. However, this piece down here says x can either be a number that's less than -2, that's like -3, -4, -5, more and more negative, or greater than or equal to 4, so that could be like 4, 5, 6. Notice those are not numbers between -2 and 4, so it's not A. If you look at B, B has graphed a solution instead of giving it symbolically, and if you look at your graph, we have a shaded in from 0.5 up to 3, and it's shaded between, which means any number between 0.5 or 3 could be the solution, and only those numbers. None of these numbers are between 0.5 and 3, so I believe B is out. Same thing if we look at D, skipping C for now, if we look at D, D has shaded from 0.5 negative and to the left, and from 3 and to the right. So this would be like if x was less than or equal to -0.5, that'd be this part, and this would be or, because it could be on the other side, x is greater than, not equal to, x is greater than 3. Well, that's great, but that's not our answer. So that one's out of this too, and I think our final answer is C, which exactly matches our answer, which is great, and we should be set. If you wanted to guess and check, you could also just pick a number that's less than -2, like -3, and plug it in here. If it works, you're on the right track. Try a number greater than 4, plug it in here. If that works, you're on the right track too.